In this video, we're going to look at a mind-reading number trick. Okay, Sue, I want you to think of a number from 1 to 15.
Okay, Bob, I've thought of a number from 1 to 15.
Right then, Sue, I'm going to read your mind. Is your number on this card?
Yes, it is, Bob.
Excellent, Sue. And is your number on this card?
Yes, it is, Bob.
Splendid, Sue. And is your number on this card?
No, it isn't, Bob.
Magnificent, Sue. Lastly, is your number on this card?
Yes, it is, Bob.
Well done, Sue. Your number was 11.
Gosh, Bob, that's amazing. You're right. However did you know?
Well, Sue, I'll tell you shortly after I tried my trick on the people watching this video. The problem is that I can't hear them, so it's going to be a bit tricky to do, but let's give it a go. Okay, folks, I want you to think of a number from 1 to 15. Now, if your number is on this card, if it's 1, 3, 5, 7, 9, 11, 13 or 15, I want you to write down the letter A. And if it's on this card, if it's 2, 3, 6, 7, 10, 11, 14 or 15, then I want you to write down the letter B. Now, if it's on this card, if it's 4, 5, 6, 7, 12, 13, 14 or 15, I want you to write down the letter C. And if it's 8, 9, 10, 11, 12, 13, 14 or 15, I want you to write down the letter D. Okay, if I'd heard your answers, I'd be able to instantly tell you what number you'd thought of. But because I can't, this is going to be a bit painful. You should have 1 or 2 or 3 or 4 letters written down in front of you now. Now, if you'd just written A, then the number you thought of was 1. If you just wrote B, then the number you thought of was 2. If you wrote A and B, then you were thinking of 3. If you just wrote C, then you were thinking of 4. But if you wrote A and C, then you were thinking of 5. While if you wrote B and C, you were thinking of 6. Now, if you'd written A and B and C, you were thinking of 7. But if you just wrote D, you were thinking of 8. If you wrote A and D, you were thinking of 9. B and D, 10. A, B and D, 11. C and D, 12. A, C and D was 13. B, C and D was 14. And if you wrote all 4 letters, you were thinking of 15. Well, it's a bit less impressive done that way, but how does this work? Well, it's all down to binary. Now, we normally do our mathematics in base 10, or the denary system, with the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. If we look at the place value of our digits in base 10, we have a ones column telling us how many ones our number has, a tens column telling us how many tens our number has, a hundreds column telling us how many hundreds our number has, a thousands column telling us how many thousands we've got, and so on. Now, the column values are powers of 10. The ones column is 10 to the power of 0, the tens column is 10 to the power of 1, the hundreds column is 10 to the power of 2, the thousands column is 10 to the power of 3, and so on. So a base 10 number like 1, 2, 3, 4 means we've got 4 ones, 4 times 10 to the power of 0. We've got 3 tens, or 3 times 10 to the power of 1, 2 hundreds, or 2 times 10 squared, and 1,000. So that's 1 times 10 to the 3. And to evaluate that, we've got 1 times 1,000 plus 2 times 100 plus 3 times 10 plus 4 times 1. Or 1,234 as we'd normally say that. But in the binary system, base 2, we only use the digits 0 and 1, and the columns have different values, 1s, 2s, 4s and 8s. And that's basically 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, and so on. Now let's have a look at how we'd represent the base 10 numbers 1 to 15 in binary. The base 10 number 1 is exactly the same in binary. We've got 1, 1. But to represent the decimal number 2, we don't have a 2-digit in the binary system. So we have to say we've got 1 of the 2's from the 2's column, but no 1's to add onto that. So 1, 0 is 2 in binary. To represent the decimal number 3 in binary, we need to count up. We've got 1, 2 and 1, 1. When we add them together, 2 and 1 make 3. So in binary, 3 would be 1, 1. Then the decimal number 4. Well, we can put a 1 in the 4's column because it's got one of those, but we don't need any 2's and we don't need any 1's to add to that to make it 4. So the decimal number 4 is represented in binary as 100. Then 5 would be 101. 6 would be 110, that's a 4 and a 2 and no 1's. Then 7 is 111, 8 is 1000, we've got 1 8 and no 4's, 2's or 1's. 9 is 1001, 10 is 1010, 11 is 1011, and 12 is 1100. 13 is 1814, no 2's and a 1. 14 is 1110, and 15 we need an 8, a 4, a 2 and a 1, so it's 1111. Now let's write the column values as the first number on each of the cards. So that's 1, 2, 4 and 8. Now we can write all of the numbers that have a 1 in the 1's column on the first card. Now we've already written the 1 on there, so next up is the 3, then the 5, then the 7, then the 9, 11, 13 and 15. Now we can write all the numbers that have a 1 in the 2's column on the second card. Well, we've already written the 2, but we need to write the 3, the 6, the 7, and then the 10, 11, 14 and 15. Now we'll write all the numbers that had a 1 in the 4's column on the third card. So that's 4, 5, 6, 7, 12, 13, 14 and 15. And then all the numbers that have a 1 in the 8's column on the fourth card. So that's 8, 9, 10, 11, 12, 13, 14 and 15. Now if we remember how to work out the decimal value of a binary number, what we have to do, for example with 13, we've got 1, 8, we've got 1, 4, no 2's and 1, 1. So we just need to add those digits together. 8 plus 4, we don't need any 2's but we need a 1. 8 and 4 is 12 plus 1 is 13. And that means to work out what number your friend was thinking of, you just need to add up the top left number of each of the cards that they said their number was on. So remember in our first example, Sue said yes to cards A, B and D, so I just had to quickly add up 1, 2 and 8, and that makes 11. Easy. Now here's your challenge. Can you make a new set of 5 cards to tackle numbers in a puzzle from 1 to 31? You'll need to make up a table of the binary versions of the numbers from 1 to 31 and then work out which numbers go on the 5 cards with 1, 2, 4, 8 or 16 in their top left corner. Pause the video now if you want to have a go and then check back to see if you were right. Okay, here are my 5 cards with 1, 2, 4, 8 and 16 in the top left corner. What numbers did you have for card 1? Well, it's all the odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29 and 31. And all the numbers that had a 1 in the 2's column were 2, 3, 6, 7, 10, 11, 14, 15, 18, 19, 22, 23, 26, 27, 30 and 31. All the numbers with a 1 in the 4's column were 4, 5, 6, 7, 12, 13, 14, 15, 20, 21, 22, 23, 28, 29, 30 and 31. All the numbers with a 1 in the 8's column were 8, 9, 10, 11, 12, 13, 14, 15, 24, 25, 26, 27, 28, 29, 30 and 31. And all the numbers with a 1 in the 16's column were 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 and 31. And here's a handy top tip. If you write the top left corner number 1, 2, 4, 8 or 16 on the back of the appropriate card, you don't even have to look at the numbers on the front of the card to show your friend when you do this trick, so it'll look even more impressive. Good luck and have fun. When you subscribe to our channel, remember to click the bell to ensure you get notifications about our new videos. And for more mathematics content, why not follow the link in the description below to nagwa.com.